the geomorphological processes, right? That is happening. For landslide, obviously, big slope, aspect, curvature, segment transportation index. Okay, so many variables that you could be able to derive from elevation data. So, what are those sources? LiDAR. Now you know what is LiDAR. You're expert now in LiDAR. Okay. Contours. That is actually the traditional way. If you can't have, let's say, we don't have a very poor people, you can only go to the what do you call, Department of Survey, and we can collect the contour data. You can also derive a visualization model. Okay, but depending on what is the contour interval. Okay, let's say over 300 contour interval, and you want to make 1 meter grid size, it's a disaster. You are overly exaggerating. With less number of data, you're just trying to make it. That's not right. So that scale factor you should understand. That's why I did mention that scale. And that should match. Okay? Then you can also from topodm, okay? And element at risk, you can also, so many, what you call data that you can capture. War data, that means parcels. Or polygon data. Map, polygon, then building map, roads, then the hazard data can be landslide ID, flood, 100-year return period, river, forest fire, location of the fire, okay, and so on. Okay? Satellite, I think this is no need, but obviously the satellite data are a very useful way of doing the interpretation, both manual interpretation, that means visual interpretation, and also digital interpretation as well. That means classifying the image either by unsupervised classification or supervised classification. Unsupervised classification means you are telling the computer to do the classification by its own knowledge. Sometimes it's okay, because if you have a big area and you are not really concerned about the level of classification accuracy, you can do unsupervised classification. Okay? But I would of course go for the supervised classification. But it's a lot of work. Okay? And also satellite data is very useful when you want to display the information at the end as well. Because then at least you can be able to visualize much more better. Right? Because you see, you can see the buildings, bridges, everything. So you can drape it, your risk or hazard or whatever, to see the visualization, to improve the visualization ability as well. Okay? Some examples of high resolution image data. You can see this is a high resolution, pretty much clear. You can see the goalpost also. Okay? And this is the hill setting of the image. That means you can get actually from the digital elevation model. Okay? Whatever. Just project it. No. Yeah. Okay. Oh, Pradhan. Okay. What are the things that you see here? The buildings, right? Building footprints. Okay. Then, yesterday we are mentioning about raster data. So in the ArcMap, you have the raster calculation in ArcGIS. This afternoon we will have tutorial, and then we will have basic GIS, introduction to basic GIS, and also you will learn a little bit more about this simple assessment. Okay? So, and you can see here, you can do the ArcMap calculation also, and you can determine by overlaying, or you can do also by clipping or zonation or tablet analysis. All these things you can do it to show the different type of color coding as well, to indicate which are the areas of high vulnerable or high risk or high hazardous, high susceptible, and so on. Okay, so this one is finished. Now let's go to any questions you have? questions means two things. Either you have understood everything, excellent, or you have not understood anything.
We have asked during the lectures whatever questions we have. During the lectures only we asked whatever questions we have.
Okay. Now, let's continue with the spatial data that we need for the hazard assessment. Okay. No? Coming already? Okay. We will try to learn what data that we will need. Obviously, I already mentioned about satellite data, digital elevation model. Okay. How do we get this data? Also, I have briefly spoken about in the last 2 days. Okay, direct way, indirect way, and so on. And also how to collect some new data and all the equipments that we have so far learned about it, right? Like what? The LiDAR system, the laser scanning system, the GPS systems, and all those things. Okay? And then maybe we do some group exercise. I'll give you some exercise. Okay? Already we spoke about the risk. This also we have understood hazard multiplied by vulnerability multiplied by amount of element at risk, right? In the last lecture we have spoken about it. Imagine of this scenario. This is a river here. Okay? Now this is a river, and in the bank of the river, this is the original river. Okay? Can you see? The white one, this is the original river. Now the bank of the river, obviously they have very nice river houses. No? Water view houses. In Sydney, if your house, from your house you can be able to see a little bit of Pacific Ocean, the price goes in millions of dollars. Okay, so they have water view here, river view. Okay, still not too bad. So you can see there is one house here. This is the depth that is mentioned. Sorry, this is the this is one house here. There is another bigger house here, and there is another moderate type of house here, and they are all being located at different elevations. And we know actually the exact the channel, the river, right? Now, how to calculate the element of risk here? Are what we have A, B, C, right? No, nothing else we have it here. There are no land use, there is no crop activities that is happening, just in the case we are having only 3 type of houses here. A, B, C. Okay? You can see here, element at risk, we have put it here. Temporal probability would be equal for all. Okay? Let's say assuming 0.1. Okay? Temporal probability 0.1. Okay? Now, when it comes to amount, the economic value, obviously, this one, the construction is a big house, right? And then the content of the house also will be more. The construction of the house also will be more. So the pricing is given more, almost double the price of this one. A. And the size also is double, isn't it? Now the smaller one is, let's say, $50,000. The medium one, the A is about. A is what? I put 100,000, 8 lakh, ये 50,000, ये है 2 lakh. Okay. Vulnerability when you carry, this is a separate, right? Vulnerability would be, I said, depending on the asset value. Correct? You can see that the vulnerability, again, also coming actually to this particular scenario. Let's say this is the flood scenario that we are calculating. Okay. Now let's say we are calculating about 100-year flood return. Okay. This line, what you see, the blue line, is the 100-year flood return. That means this is what actually we inundated. This would be the scenario of the flood. Okay. I mean scenario of the flood. So that means model flood level with, sorry, here 10 years. Let's say 10 years. Forget about 100 years, too long. 10 years. Okay. Now. And here it is mentioned actually the depth as well. Doesn't matter the depth, okay. in this case, what you see here, A, what happens? How many? It still actually is not totally submerged, right? Right? You still have actually, let's say, upstairs you still can run away. Okay? If the construction is very good. Assuming they are all well constructed houses of concrete, not wooden houses. Otherwise you would have a nice floating house. Okay? So in this case, A is given 0.1. Okay? Because obviously the cost is not that high, and also is only, and also you can see that its submerged is not too much. Only one level that is being submerged here, the ground level. Okay, that's why it has been given 0.1. B, finished, totally gone. And I said it has to be 0, 0 and 1. So here it is given 1, totally damaged. Now you understand this concept. 1 is totally damaged. Now if you go to C, obviously it's a bigger house. Construction cost is high. But if you look at it, it's almost 3/4 of the house is being submerged. That is why it is given 0.5. Now, who gives this value? This is why the economics comes into also play. Okay? That is why on the left hand side I put what? Risk is a multi-hazard, it's a multi-sectoral, it is a multi-level, it is a multi-stakeholder and multi-phase. So risk assessment, that's why the insurance people also comes in, the economic guys also, finance people also comes in. Okay? So it's a multi-sectoral assessment. But you have the data, and if you have the export inputs coming in, you can be able to do that. Alright? So now, vulnerability we have already assigned the rank or weightage. So the specific risk would be what? What do you do? Multiply, right? So when you multiply it, it becomes 1,000, 5,000, 10,000. Okay? Understand? So that is how we calculate the risk. And you see here vulnerability, it is the damage category. And if you look at actually the meter, okay, it's the meter in depth, right? You see here A is totally submerged. Now A is, no, depending on actually different type. You have what? A, B, C. A, C, B, right? So what is happening here? So B is totally submerged anyway, right? So that is what? How many meter? 5.6 meter. So it is here, right? And then A is 0.8. Yeah. So basically this is the way that they calculate the, but I would rather depend on actually the economics guy to come and tell me what would be the specific vulnerability for a particular values attached. Okay? Now, think of it some important questions. How to answer these questions? Before we do any kind of hazard assessment, there are some specific important questions that need to be answered. Why did hazards occur before? Why did it happen here? In that particular location? Why did it happen somewhere else? Right? I did mention to you, it is the interplay between the human activities and also the physical systems. Right? That is why it makes actually the hazard to be, making it a hazard, right? What type did they occur? Again, if it is a flood, what type of flood? Seasonal flood, coastal flood, okay, flash flood, riverine flood, okay, right? There are so many types of flood. How often did they occur? What is the frequency of the hazard? Why did they happen there? What are the main cause? That's the triggering parameter. How can we map this? Where will they happen in the coming period? That's why actually we make the susceptibility map, the prediction map. How frequent will they happen in the future? That means where that we can do the temporal prediction as well. Okay? How big will they be? Estimating the footprint. Okay, not only the location but also the spatial footprint. What would be the expected damage? That is why we do the vulnerability and risk assessment. What can we do to decrease this expected damage? That's why it goes in the coping capacity, and then you can do the assessment. Are you all getting me? Is it something new information that you are learning? You already knew about all this? Huh? Yes or no? Yes. Good. Now, input data, the type of hazard is very important. That means sometimes what we do, some people think that for one particular hazard, let's say they are using X number of variables, they try to replicate the same variables for another type of hazard. Wrong. Because each hazard, as we have seen, the processes are different. The requirement of the data set also, the demand of the requirement of the data set also are going to be different, right? Therefore, earthquake hazard assessment requires very different input data than flood hazard assessment. The method also can be similar, but again they can be different as well. Okay, obviously, when you do the flood hazard assessment, you also have the traditional based flood, hydrological modeling, then you have the flood hydrodynamic modeling, and so on. But nowadays also we use the machine learning based modeling as well. Okay? And sometimes, depending on actually the kind of complexity, we use more complex model. Right? So these days they use the complex ensemble model. Okay? Ensemble model. And the scale of the hybrid model. The scale of the study is also very critical. How big? What is the area that you are going to study? The availability of resources, yes. The amount of available data. Alright? That is not big. Something happening in? Yes, sir. What? Oh, battery. Why? What is property? This one here. Up. Now let's lose. Okay. Let's now go through a little bit more detail. And in this case, this is for the landslide. Okay? There are many factors that we have to consider here. Okay? There are, what is this here, Nami? 462285. ये क्या है? अच्छा इधर क्यों आ रहा है? अच्छा तो कोने में नहीं रखा जा सकता है? अच्छा okay, you have environmental factors, you have triggering factors, then your inventory is the most important thing. Okay, inventory means time 0, time 1, time 2, like 30, 40, 50 साल का data. Okay, then you have environmental factors. What are the environmental factors? Let's say geology, soil, morphology, geomorphology, etc. Okay. Then triggering factors. In landslide, you have two types. One is earthquake, another one is rainfall. Okay, right? Man-made is already you are having the land use, and land use basically is the human activities that we are doing it, right? So therefore, it is already being embedded here. You can see that land cover, right? Land use, land cover. Okay. So this is a very detailed analysis. That means you can do also. First step, you do the what do you do? You do the susceptibility assessment. So in the susceptibility assessment, you can also do depending on the type of data that you have. Remember, every kind of assessment and the modeling totally depends on the availability of the data source. You can't achieve and can't do everything just with limited amount of data set. Okay? So you have you can do magnitude frequency analysis, okay, or you can do runout flow assessment also. If you are runout flow assessment, you do it when it is a debris flow. Remember, landslide has also got different types, right? What are they? Landslide itself, you have rockfall, you have debris flow, then also you have you have translational landslide. You know, there's so many types of landslide, right? So you got to understand what type of landslide. In the case of debris flow only, you have the runout assessment. That means debris flow means is a type of soil that is also matters the most, isn't it?
Yes.
You can't have actually clay material to have a debris flow, right? And you can't do runout distance assessment for rockfall. In the rockfall, you can do what is the distance analysis of the jumping of the rock. Right? I'll show you some examples also. Okay? Are you all getting me?
Yes.
This is, I have just given an overall framework, but this is what piece of information, what kind of data, type of input, type of landslide that you have. Based on that, you determine what you would like to do the modeling, what type of modeling that you would like to do. Okay? Then separately, you see, element at risk of vulnerability is a total separate assessment, nothing to do with the hazard. Okay? So in this case, what are the elements at risk? Building, road, land use, essential facilities, cadastral data, census data, and so on. Census means indirect way of knowing the amount of people, number of people. Janagana. Okay, that also has to be correct. I don't believe India has got 1 point. What is officially 1.4?
Yes.
I think 1.6. I think 2 crore तो ऐसे ही 2-3 crore तो ऐसे ही तो ऐसे ही because you think of it, when the guy goes to the house for Janagana, do they tell the truth first thing, or someone is in the house second thing? So there are so many people who don't have address,
Yes.
correct? So 2-3 crore क्या उससे ज़्यादा 10 crore तो ऐसे ही डाल है कि नहीं? कुछ भी हो सकता है. So, I'm being recorded actually, and that is by the ministry. But doesn't matter. So elements at risk, right?
Yes.
And then you create the scenario development. Finally, output of this hazard you calculate hazard, okay? Calculate the vulnerability, then you calculate the amount, everything you calculate actually the risk. Either you would want to calculate the specific risk, or you would want to calculate the total risk. Total risk, how you would calculate? Let's say, that means the vulnerability also you have to do 4 types of vulnerability assessment. Okay? That means you do economic, physical, social, environmental. All of them you bring in, then actually you calculate the total risk. Okay, so now next time if someone says that risk, what kind of risk? That's very important to know. Alright? And when we are talking about total risk, that means it should be already embedded with all hazard types, all return periods, all triggering events, all elements at risk. Not easy. Collect all data and do everything. It's not easy. Okay. One assignment for you. You have to do it in the tutorial this afternoon. Okay. What is the assignment here? Form groups of 4 or 5 people. You can have your friends with you, no problem. Okay. Select a hazard type and define which sector of element at risk. Okay. Depending on the background that you have or the project that you are working on. Then we can have discussion. Okay. Define which sector of element at risk, which level of analysis, that means the scale that you would like to do. Which stakeholder is involved? What are the stakeholders? Stakeholders, you know, right? Agencies. Okay. Which phase of disaster management cycle that you are going to address? You have the disaster management cycle. I said preparedness, early warning, then also I said the risk assessment, vulnerability assessment, right? The entire thing. Mitigation. Which part of the disaster management cycle that you going to address? Very easy. दोस्तों के साथ. Okay? Make a flow chart and indicate which types of data are needed for hazard, vulnerability, and risk assessment. If you can be able to do this, I think 60% of the problems are solved. So figuring it out logically, identifying the problem and what sorts of data that you need, that will solve the main hurdle of your बाकी जो चीजें हैं ना मॉडलिंग एक्सेट्रा एक्सेट्रा दैट कैन बी डन. अगर fundamentally you have collected wrong input data, you are making another new type of disaster, which is not included inside that. Okay? सब करना पड़ेगा. Okay? Landslide risk assessment. This you would be very familiar with if you would have read many of my papers. Okay? Again, you have said the environmental factor, triggering factor, inventory. Inventory 10 साल नहीं, 50 साल, 60 साल, 100 साल, जब तक है data लो. Okay? The more you that, the more data you have, the merrier it is. Okay? Because then you can understand more. Okay? Why this? Because sometimes what happens is that for a particular, let's say you have very limited amount of data, then your understanding about the how the system has played role would be weak, very weak. But the more data you have, the more understanding that you have. Okay? Then, okay, I think this one I can skip. I have already mentioned to you. We'll do a simple also calculation. This also I have already mentioned. Right or wrong? If I say in this case, hazard means what? How much water, in the case of flood, how much water, when, and where. That is what actually is going to tell you the hazard. Element at risk means which element at risk are going to be, where and how much and how many. Vulnerability, how much water, where, which element at risk are there. Okay? See, again and again I am trying to reiterate these things because these are the basic fundamental of doing any assessment, of your assessment. You get this thing wrong, everything goes wrong. Okay? So now we know risk is a multidisciplinary approach. Right? And if you look at it, you will be surprised. Hazard assessment are normally done by the earth scientists, hydrologists, volcanologists, seismologists, depending on the type of hazard they are dealing with, right? Element at risk are done by geographers, urban planners, civil engineers, and so on. Cost estimation always should be done by economists. Vulnerability done by structural engineers, civil engineers. Building, okay? Structural building. You know, type of building, strength of the building, and so on. Let's say the calculation that we have done, right? 0.1, 0.5 and all that. What if actually the building structure is different? I assume the hypothesis I have taken that all buildings are of the same concrete type. Now, the bigger house that is what was there, if it is a wooden one, although it is 3/4 is only being submerged, but everything will be floating, right? That is why the structural engineers have to come in. Risk assessment done by the spatial scientists, spatial engineers. Okay? All right. Risk assessment needs GIS. Everything you need GIS. Okay? Now, let's understand more. Characterization of the hazard. Reach of the hazard and duration of the hazard. Because I said duration, time. Reach means the spatial footprint. Okay, let's understand about it. Now, some of the hazard, it can go into excess of 1,000 kilometers, the reach of the hazard, and some can be very localized. Right, I have given, I think you can't read here. So, यहाँ पे देखो, बहुत छोटा हो गया ये actually. देखो, wildfire इधर है, you can see the symbol. Wildfire. It can be in the excess of small area, that means few hectares to hundreds of kilometers of hectares also. Okay? Then you have flooding, less than 1 kilometer, it can go about even much bigger area. As you come here, landslide, less than 100 meters. Or you have also landslide run into 5-10 kilometers. So when I was in Germany, I used to go very frequently to collect some data from Turkey. Okay, with some of my colleagues who are expert there. Okay, renowned professors in Turkey. So initially, I was not exposed to those kind of earthquakes because I had no earthquakes actually here, right? No Sivalis and all that, right? So when they showed me those landslides, it's unbelievable. It's about 6 kilometers long, 7 kilometers long. So when we used to do the analysis, they used to make fun of my data. You call these are the landslides, right? So it depends. Earthquake generated landslides or trigger landslide can be of long length. They can be big. Okay. Then you have landslides. You have subsidence. Land subsidence always in less than 100 meters. Okay. And so on. Then gully erosion. Okay. So it says there are so many types of hazard that I have mentioned here. Now there is one tsunami, more than 1,000 kilometers. Okay. Then you have what? Asteroid impact, the whole earth. Right? Right or no? When the asteroid comes, it is not going to look at whether it's the boundary of India and Pakistan boundary or India Bangladesh boundary. Huh? Agree with that. Yeah, maybe that is what actually made the extinction of the dinosaurs. That's what they believe in. See, if one Krakatoa mountain, volcano, could actually disrupt the entire Earth for a decade, you're talking about one asteroid coming at the speed of how many thousand kilometers per second, coming and actually hitting us. Okay, amazing.
Even the
I think it's been predicted one is coming towards Earth now. What's that?
Even the height was bigger than Mount Everest, which is submerged by the ocean of Krakatoa.
Yeah. Duration of the hazard, again, it lasts from seconds to years, right? You can see the same type of hazard. If the duration, sometimes it can be minutes, sometimes hours, sometimes can be days, like fire. Fire doesn't go actually for years, right? Then the सब कुछ जल जाएगा, ठीक है? Then you have weeks, some, and then like coastal erosion, it takes years. Like slowly and slowly the coast gets eroded. Right? Then you have some other type of geohazard also takes drought. Drought can be century also, can be 100 years. Like Australia is already having a drought, as we are speaking, for almost 100 years. Millennium drought, huh? हाँ वो तो चल रहा है. Yes. So what a waste of resources, huh? But what to do? You can't put it off. It's one of the Jharia coalfield is the biggest coalfield, right? This is what, not far, right? 20 kilometers from here. Understanding? Are you getting me or not? Okay. Now, if you want to plot it in terms of duration and also the reach here. So this is the duration and this is the outreach or reach. You can put them actually the different types of hazard, where do they fall. El Nino, global, right? Climate change is global, isn't it? So when you do the climate change assessment, obviously you have to take those models which has more of global climate change models, not Indian climate change model or Kerala climate change model. Okay. Then ozone depletion, that's actually a global phenomenon anyway. So already have spoken about it. So hazard varies partially, temporarily, and this is what I mentioned actually. When the frequency of the hazard increases, the magnitude decreases, more or less. Okay, that is the common phenomenon. So most of the hazard events you can see that is inversely proportional to each other. Okay, but in the case of flood and drought, there is a bell curve. You know, like when you do the marking in the class, especially we have to attain a bell curve. This is what we have to attain when we do the grading of the class, readjusting actually the grade of the students. Okay, then these things I think no need to understand more. It's more complicated for you. Essential, as I mentioned, is inventory. Without inventory, you can't do much. You can do a scientific based assessment. How do you now collect one inventory. How? There is a direct approach. Obviously, if you be lucky, if there is an agency already is having a very good record of the events, fantastic. But very unlikely. If you are looking at maybe last 10 years of data they might be having, ever since actually this computerized, centralized system has happened. But beyond that, it's very hard, right? So, existing catalog, you have to find records, seismic catalog, discharge measurement, rainfall records, blah, blah, blah. Then you have to look at the time span and the completeness. Okay? Historical study of archives, newspaper, log books, etc. also is very important. Multi-temporal imagery, satellite images or air photos, that is where actually you can you can look at the past and see to that if there are any changes that have happened, you can delineate it, but you need to validate it. Remote sensing based information, when you are trying to use as a primary source of information like this, that need to be verified. Because remember, this is again the whole electromagnetic spectrum coming, reacting, interacting, then you are capturing some of the reflectance values, converting them into digital number at different weather conditions, atmospheric conditions. So obviously that need to be verified, especially whether that event has happened. So field verification is a very important process.
So
okay.
What is the past data?
You can still go and collect it. So you collect this, now you try to tally. Now you tally, Google search, maybe in the newspaper you found there was an article published. Done.
What would Google have to
Yeah, okay.
asking you to?
Yeah, but I would still go to the field and ask the community, because they are the right people, they are the people who have been affected by the event. See, even the 100 years old event, people will remember if it was a big event. You go and ask some villagers can be able to tell you, what right? Like that. So those are confirmation. You just don't actually carry so much of uncertainty in the data. Because once you have uncertainty in the data, in the modeling it is going to be bigger and bigger and bigger and bigger. You would like to reduce the uncertainty of the data, right? Input data. Then field mapping, landslide, floor marking, but should not be too long ago. It was about 100 years ago, it's done. Okay? हमारा तो खुद का हिस्ट्री नहीं मिल रहा है हमका, सब तो जला दिया गया, right? Okay. All right. Interviewing population, participatory modeling. That is what we call participatory modeling. This is a branch by itself. Community participatory modeling. Okay. So remote sensing data, you will know that. I think I can skip this. I have already mentioned so many. This also I have already mentioned yesterday or day before yesterday. I still put 50 kilometer is Meteosat, 1 kilometer NOAA, 30 meter thematic mapper, 10 meters for 5 meter in the remote sensing data, which is 4.8 meter, 5 meter. Then KBR, Korean satellite is about 2 meter, Iconos less than 1 meter. See, car is making a turn also, you can be able to see. But this is nothing. We have actually 15 centimeter data satellite data. Okay? Any questions so far? This also I think I can skip, I have already mentioned, but it's for you very important to understand. Based on the spatial and temporal scale, see, because some of the data, let's say, if you are using a land use land cover map for your analysis, and the land use land cover map that you have from the so-called agency, they prepared in 1990. Now you are using actually as your input data. That's rubbish. Land use land cover 1990. Now this is what, 2025. Everything has changed. Because new settlement had come in, new roads have come in, the entire landscape had changed. So those are the data you must get as recent as possible. Okay. Classification, I think I don't have to talk about it. Google Earth Engine is a very important source piece of information because it can also tell you historically And you can do a lot of modeling there also. A lot of free plugins are there. Right? Okay, so don't think that Google Earth Engine is not that much useful. It's a very useful source of data. Okay? You see here, for example, I put a nice example here. See, 1 kilometer, this is what? Squatter areas you can be able to see. Small single family houses also you can be able to see. Small single family houses, you can delineate them. You know, individually, if it's a small area, you can do the digitization also. Or you can engage actually, if you are good in image processing, you can do that. Okay? And then obviously you have the some digital regression model as well. Okay? I have listed down a lot of free source of data source that way you can be able to download the data. Okay? So the question comes in which data to use. That actually is the major problem. Yes, the modeling is not a problem. Why would you worry that much? The most important thing is the what sort of data set that I am going to use. Okay? Digital terrain model. The free data set is basically SRTM, which is about 30 meters spatial resolution, pixel size. Okay? But there is also called Alos Polsa. Okay? That's also free. Alos Polsa is a Japanese satellite. Okay? You can get it for 12.5 meter. So this is fantastic. Okay? There is another source of data which is called Tandem X. It's a German satellite. Okay? You can write down. No. What color we want? Red. It's from DLR, German Space Center. Okay? Alright? But that's not for free. Some data they have for free. But initially when they launched, obviously they were asking a lot of researchers around the world to utilize that data for free to see actually the capability of that data set. So many of these programs, there is a call for proposal whereby you could request actually for free data. Just a very short proposal of 2 pages, what you are doing, what is going to be your expected outcome. You can submit the proposal directly to them. Or if not, you can also write to them as well. If you are doing some research, sometimes you can be able to write to them. That this is the research I am doing, this is the data that I would like to have, and blah blah blah. So obviously you are going to acknowledge that in your research and blah blah blah. It's possible. Okay?